Okay, 0.3, exponents and radicals. Okay, let's start with 0 and negative exponents. Okay, end of the 0, 1. Anything to the 0 power is 1 except for 0 to the 0 power, which we shall not talk about. Okay, now what about negative exponents? Okay, negative exponents mean that the base is not in the correct place on the fraction. So if I do x to the negative fifth, it means that the x should actually be in the denominator in order to make the exponent positive. It's nicer to write your answers with positive exponents, so often when it asks you to simplify it, it will ask you to include positive exponents. So x to the negative fifth is 1 over x to the fifth. Okay, for C, I have x to the third, y to the negative fourth. Now the x to the third is fine. It has a positive exponent. It's a nice answer. The y to the negative fourth is a problem because the exponent is negative. Since the y has a negative exponent, the y needs to move to the bottom so I can make the exponent a positive 4. And then that's my answer. It has positive exponent, which makes it a better answer. Okay, let's do a couple more. Okay, for D, let's see, what's wrong with this? 5? 5 is fine. What about the m? The m has a negative exponent, so I'm going to move the m to the bottom so I can make it positive 2. Now for the n has a negative exponent. It's n to the negative third, so the n also has to move to the bottom so I can make it a positive 3. So for 5m to the negative 2, n to the negative 3, the m to the 2, and n to the 3 move to the bottom. Okay, and then that's my answer because it has positive exponents, and there was nothing to combine. Let's look at the next one. Okay, 3, I'm fine with the 3. I mean, technically there is a 1 on this, so 3 to the 1, which is a positive exponent. Okay, the n has a negative exponent, so I'm going to move it to the bottom to make it a positive 5. The y is fine. Y to the second. Leave it alone. So the 3y to the second stayed. The n moved to the bottom, so it could be n to the fifth. Let's look at the last one. Okay, the 4s, it's fine again. Is the x okay? No, the x has a negative exponent, so I need to move it to the bottom. The y to the second is fine where it is. It has a positive exponent. It is at the bottom, so I'm going to keep it at the bottom. The order of these at the bottom doesn't matter because when you multiply, it doesn't matter which one comes first, but they should both be at the bottom. Okay, next thing we should review, multiplying monomials. If you are multiplying monomials, you're going to multiply the coefficients. You're going to add the exponents on the common basis. So if I do x to the fifth times x to the third, they both have a base of x. So I'm going to add the exponents. So it's x to the eighth. Okay, and that's a better answer. I condensed everything I could. Let's start with the m's. I have m to the fourth. M, what's the exponent on the m? 1, yeah. M to the fourth, m to the 1, and m to the 7th. So I can consolidate into the 4 plus 1 is 5, 5 plus 7. I can make this m to the 12th. Let's look at the next one. Okay, x to the 5th. Are there any other x's? Yes. So x to the 5 plus 4 is 9. For the y's, I have y to the second, y to the third. 2 plus 3 is 5. Okay, simplified. I combined all the common bases as much as I could into a single monomial. Okay, now I have 5x to the third, 2x to the fourth. The 5 and the 2 are called coefficients. Coefficients are normal numbers. I'm going to multiply the coefficients. So 5 times 2 is 10. Yeah. Then I have x to the third, x to the fourth, x to the 3 plus 4, 10x to the 7th. Nicer answer. I multiplied what I could multiply. I combined things with the same base. Okay, let's try this one. 6 times 5, 30. For the x's, I have how many here? 1 plus 8. 30x to the 9th. Let's try one more. 8 times 2. Multiply the coefficients. For the x's, x to the 10, 2, x to the 12. Y to the 3 plus 6, y to the 9th. So 16, x to the 12th, y to the 9th. I multiplied what I could multiply. I combined things with the same base. That's my simplified answer. Okay, how about dividing monomials? Okay, we're going to divide, simplify the coefficients, subtract the exponents on the common basis, making sure the base on your final answer is where the highest exponent was, and all exponents are positive. Okay, so if I have x to the 9th at the top and x to the 2nd at the top, If you imagine I had x 9 times and x at the bottom twice, I'm going to cancel out 2 of them. If you cancel out 2 of them, 9 minus 2 means I'm left with x to the 7th. Okay, when you're dividing or it's a fraction, things are canceling. So you're subtracting what's going to cancel. Okay, let's look at this next one. It says n to the 4th over n to the 6th. There's n at the top. There's n at the bottom. If you cancel out the 4 n's they have in common, what are you left with? I'm left with n to the 2nd. Is it at the top or the bottom? It's at the bottom because there were n to the 6th at the bottom. There were more n's at the bottom. There's nothing left at the top. So my answer is 1 over n to the 2nd. Okay. If you learn to do a negative exponent first and then convert it, let's look at that too. Some people just learned I'm going to do top minus bottom. If I do top minus bottom, then I get n. 4 minus 6 is negative 2, which is fine, but I can't leave a negative exponent, so then I would rewrite it like this. So if you like to do the negative exponent first, do that first. If you like to skip to the simplified, that's fine too. It's up to you. Okay, let's look at C. Okay, let's just look at the m's first. I have m to the 7 at the top, m to the 2 at the bottom. What am I canceling out? I'm canceling out 2 of them. If I cancel out 2 of them, 7 minus 2, I'm left with m to the 5th. Is the m to the 5th at the top or the bottom? Top, because there's more m's at the top. So m to the 5th is at the top. Okay, what about the n's? I have n to the 3rd and the 11th. I can cancel out 3 of them without running out. If I cancel out 3, 11 minus 3, I'm left with 8. Where are the 8? They're left at the bottom because there were 11. There were more at the bottom. So this is my final answer. Okay, now again, if you learned this different last year, or in Algebra 1, let's do it that way. If I do, some people just learn top minus bottom. If I do top minus bottom, I get m to the 5th. N to the top minus bottom, 3 minus 11 is negative 8. After you write m to the 5th, n to the negative 8, you rewrite it like this so it has positive exponents. So it's fine if you would like to do that. Whichever method is comfortable for you is fine. Okay, let's look at D. D has coefficients. Coefficients are normal numbers. So if I do 14 divided by 2, I get 7. Okay, then I'm going to worry about the exponents. I have x to the 2nd over x to the 8th. 8 minus 2, I'm left with 6. Where are they? They're at the bottom. So my answer is 7 over x to the 6th. Okay, I'm going to do it the other way for people who learned it the other way. Okay, 14 divided by 2 is still 7. X to the, if I do top minus bottom, I get 7x to the negative 6th. And then once I rewrite it, I get this answer. Okay, let's try E. Okay, 12 divided by 2 is 6. Let's see if I have x to the 7, x to the 4. 7 minus 4 is 3. Where are they left? Top. So I get 6x to the 3rd. Let's try one more. Okay, 10 over 16, does that divide? I can't divide it, but I can simplify it. What can I divide out of 10 and 16? They both divide by 2. So let's make this 10 divided by 2 is 5. 16 divided by 2 is 8. Okay, for the x to the 3rd, x to the 8th, 8 minus 3 is 5. Where does it go? It goes at the bottom. So this is my final answer. Okay, I'll do it the other way for people who are used to the other way. I would still have to simplify it to 5/8. If I do top minus bottom, 3 minus 8 is negative 5. And then when I rewrite it, it turns to this answer anyways. Okay, how about power to a power? Okay, let me do A the long way, and then I'll show you the shorter way. Okay, if I do 4x to the 7th to the 3rd, what am I really doing? I'm doing 4x to the 7th times 4x to the 7th times 4x to the 7th. Which is fine. But if I'm doing it to like the 5th, I don't want to have to write it out 5 times. So if it's something with an exponent raised to a power, it's a monomial raised to a power, I can kind of distribute the exponent. And let's see what that looks like. So if I take the 3 and I distribute it very carefully to each term, so it has to go to the 4, so that's 4 to the 3rd. And then I'm going to distribute it to the x. When I distribute it to the x, I'm doing 3 times 7, which is 21. Now 4 to the 3rd is 4 times 4 times 4, which is 64. And then this is x to the 21. Okay, now if I had written it out, it would be the same because I had 4 times 4 times 4, because I wrote it out 3 times, 64. And then I had x to the 7th, x to the 7th, x to the 7th. When they add them up, 7 plus 7 plus 7, 21. Let's try the next one. Okay. You just have to be really careful when you do the shortcut. The 3 needs to distribute to everything on B. So for B, I'm going to distribute the 7, so I got 7 to the 3rd. Now if I do x to the 5th, and I distribute the 3, I'm going to multiply. So it's 15. Why am I multiplying? Because if I write it out 3 times, I have a x to the 5th, x to the 5th, x to the 5th, and I'm adding up the 5 3 times. Okay, for the y to the 4th, 3 times, y to the 12th. If I do z to the 10th, 3 times 10 times 3, 30. What is 7 to the 3rd? Okay, it is 343. X to the 15th, y to the 12th, z to the 30th. Okay, one more power to a power. Let's distribute. Okay, it's a monomial to a power, so it's 2 to the 5th. If I do m to the 3rd 5 times, I get m to the 15. If I do n to the 7th 5 times, I get n to the 35. 2 to the 5th, 2 times 2, 4, times 2, 8, times 2, 16, times 2, 32. Okay, now let's look at radicals. Radicals are square roots, although they could also be other kind of roots, but we haven't learned the other roots yet. Okay, so for A, the square root of 36, what is it? Yeah, it's 6. Why? Because 6 squared is 36. So the answer is 6. It's a rational number. Comes out nicely. Okay, let's do B. B is the square root of 9 over 49. When you have a fraction, you're going to consider the numerator and denominator separately unless you can simplify them in some way. So if I look at the top, the square root of 9 is 3. It's nice. What about the bottom? The square root of 49 is 7. So the denominator is 7. So my answer is just 3/7. Is this still a rational answer? It was a nice fraction. It came out nicely. Now the square root of 63. Yeah, that's not a perfect square. It's irrational. But we did learn how to simplify these in Algebra 1, so we're going to simplify it. By simplifying it, we're going to make the radicand smaller. Okay, now there's a couple ways to do it, and some of you might do it in your head too. Okay, so one way to do this would be to think of 2 things you multiply to get 63 such that one is a perfect square. So that looks like, what do I times to get 63? Yeah, 9 times 7. The square root of 9 times the square root of 7 is the same as the square root of 63 because 9 times 7 is 63. What's the square root of 9? It's 3. What's the square root of 7? It's irrational. I don't know. So this is 3 square root 7. Okay, some of you learned this using a factor tree, which is also fine. Okay, if I do a factor tree, I'm thinking, what do I times to get 63? Well, 9 times 7. Can I break this down more? What's 9? 3 times 3. I'm looking for squares, so I want something times by itself. Since 3 times 3 is 9, this is my perfect square, it goes on the outside. This is my leftover single, so that stays in the radicand. And I would still get 3 root 7. So whichever method you use is fine. Just make sure you got it. Let's try square root of 40. Do we know it? Nah, irrational. Okay, if we can simplify it, we should. Let's try. If I do 5 times 8, that's not helpful. I could do 4 times 10. That is helpful. Why do I like 4 and 10? Because the square root of 4 is 2. The square root of 10, I don't know. But this is a better answer because the radicand is smaller. So the answer should be 2 square root of 10. Factor tree is A-okay. Let's try the factor tree. Let's do 8 times 5. Does this break down more? 4, 2, 2, 2. I'm looking for some squares. Okay, there's a square. Okay, so 2 squared is right here. So that's why the 2 comes on the outside. What else am I left over with? I have this 2 and this 5. So 2 times 5 is 10. And that's why the little 10's on the outside. Okay, let's try 2 more. Okay, these are the same, but there's a 7, a coefficient of 7 on the outside. So I'm going to worry about the square root of 20 first. And then we'll figure out the other part. Okay, 20. Can we do 4 times 5? Okay, now if you're doing this this method, can you keep the 7 in the front? Because it's not gone. It's just, we're going to ignore it for a second. Square root of 4 is 2. Square root of 5, I don't know. And when I do 7 times the square root of 20, that's doing 7 times 2 square root 5, which gives me 14 square root 5. Okay, should we factor tree it? We'll factor tree it. What should we do? Okay, we're just factoring the radicand, which is the 20. So what's 20? Let's do 2 and 10, which is 5 and 2. Let's look for the pairs. There it is. Okay, so if I simplify the square root of 20, I get 2 square root 5, because the 5's left here. And then the 7 in the front, I need to multiply it by 7. So I do 7 times 2 square root 5, and then I would get 14 square root 5. Okay, again, it's up to you how you do it. Okay, let's do one more. 3 root 50. Do we know the square root of 50? Nope. Can we break it down? Sure. It's quarters. 25 times 2. Square root of 25 is 5 square root 2, so 15 square root 2. Okay, let's factor tree it. 5 times 10, 5 times 2. There, I see it. I got those 5s. Okay, so this is 5 square root 2, which is this step right here, times the 3, 15 square root 2. Same answer.